Hi, Math 30-1s. Continuing on with trig functions today, what you're going to see is that we revisit transformations, okay? So now you're going to see transformations of trig functions, so primarily on the graphs of sine and cosine, which we have studied, okay, and taken a look at their basic shapes the last couple of days. And there will also be some on a tangent eventually, okay? But we're going to focus on sine and cosine for the majority of our questions. Now, you can see that what we have up above here are the two basic equations, okay, that are going to be associated with sine and cosine. In both of them, okay, we have an a value that comes before the sine or cosine function. Again, that a value is going to be your vertical stretch. After, inside the brackets, we have a b value, which will be your horizontal stretch. Then you have a c value, which will be your horizontal translation. And then you have a d value, which will be a vertical translation. Okay, so again, those parameters that we've seen before in other chapters with other functions apply the exact same way to the sine and cosine functions. Again, what we want to focus on is what the replacement is on the original function. Okay, and once we know what the replacement is on whether it's the x or y variable, then we will know what it does to the graph, and then we will apply it accordingly. Okay, so in this lesson, it says we are going to be focusing on a and b, okay, which again are your vertical and horizontal stretches. If they are negative, that means there is also a reflection over either the x or the y axis. And again, I'll approach that and discuss that when we see it in the equation. So it says, use the knowledge gained from transformation in the transformations unit, to describe how the graph of the given function compares to sine of x, where x is in degrees. Okay, so in this question, we're talking about x in degrees. So the first thing is in A here, I have a 2 now, okay, that is in front of sine of x. Now remember that how did that 2 get there? Well, in the original function, we would have replaced y with 1/2 of y. That is the replacement that would have occurred. And when that happens, okay, it always results in a vertical stretch by a factor of 2, okay? A vertical stretch by a factor of 2 about the x-axis. In the second one, okay, the 2 is now attached to the x, isn't it? So what would have happened is you would have replaced x with 2x. When this replacement occurs, we are dealing with a horizontal stretch, okay, by a factor of 1/2, okay, and this time it's a horizontal stretch by a factor of 1/2 about the y-axis, okay, so closer to or away from the y-axis. In the third one, okay, you can see I now have a -3 there. But because that's a negative value, I discussed the replacements as two separate replacements. You would have replaced y with -y. So there's your reflection. And you would have also replaced y with 1/3 y. So when I replace y with -y, that means I reflect over, on, or in, okay, the x-axis. So there is the reflection that has occurred. And then when I talk about the stretch, this would be a vertical stretch by a factor of 3, okay? And it's by a factor of 3 about the x-axis. Again, closer to or away from the x-axis. So a similar situation down here in the fourth one, okay? Two replacements here. You would have replaced x with -x, and you would have also had to replace x with 3x, okay? So when I replace x with -x, this time it will be a reflection in, on, or over the y-axis. And when I replace x with 3x, that is going to be, okay, a horizontal stretch by a factor of 1/3, okay? And that is about the y-axis. Okay, so again, hopefully you remember those replacements and how they are applied to our functions. So in B, it says, in which of the above examples now is there a change in amplitude compared to the graph of sine of x? So remember, amplitude, okay, is max minus min divided by 2. So I want to be changing the max and min, or the distance between the max and the min. So when there is a change in amplitude, that means there's going to be a vertical stretch. So in which of the graphs above is there a vertical stretch? Well, that would have been in example 1, okay, and in an example 3. Remember, sine and cosine go from max values of 1 to minimum values of -1 normally. When I stretch those, okay, those max and min values are altered, okay, or the distance between the max and the min values are altered. C says, in which of the above examples is there a change in period length? Well, remember, again, since we're discussing in degrees, the period length for sine and cosine is both 360 degrees, isn't it? That's the length of time, the horizontal length and time it takes for the graphs to complete one cycle. So I'm going to be changing that if I horizontally stretch the graphs. So in which graphs were there a horizontal stretch? Well, that would have been graph 2 and graph 4. Okay, so horizontal stretches are going to affect the period length. Now, complete the table. Use a graphing calculator if necessary. Okay, we do not need to do that. Okay, so what I'm going to just draw on the side here, okay, is the graph of, we're talking about sine in all of these examples here. So again, here's what sine looks like in general: max of 1, min of -1. Okay, there are x-intercepts at 0, 180, and 360. So I've drawn one complete cycle of sine. Okay, so first thing off is just sine of x. So the amplitude for good old sine of x is 1, right? Max minus min over 2, and the period length is 360 degrees. Okay, not a big deal. In the second one, I now have a vertical stretch by a factor of 2. So that means my graph of sine would now be going from a maximum of 2 down to a minimum of -2, right? I stretch it vertically by a factor of 2. So again, if I drew that one just on the side, okay, it would look almost identical, right? It would look still here, go up, go down, but now it's going up to 2 and down to -2, okay? Still, again, if I vertically stretch, those x-intercepts do not change, okay? So they would stay where they are, invariant points. But the amplitude would now be max minus min over 2, so it would now be 2. The period length would not be altered. It would still be 360 degrees. Okay. In the next one, okay, I've replaced x with 2x, so that would be a horizontal stretch by a factor of 1/2. So if I was to draw that graph, okay, a horizontal stretch by a half. So everything gets cut in half. So what would happen is now that graph, okay, would look like this, okay? It would now be doing one complete cycle between 0 and 180. The graph would be cut in half. The max and min values are still the same, okay? But the x-intercepts, for example, would be cut in half, okay? So the 360 would go to 180, the 180 would go to 90, okay? That's basically the graph we're talking about. But the amplitude, okay, would still be 1, but the period length would now be 180 degrees. The horizontal distance it takes for the graph to do one cycle. Okay, so now using those ideas, let's move through and see if we can do the other ones without graphing it, okay, or using our graphing calculator. So -3 sine of x, so there's been a reflection over the x-axis and stretched by 3. So the graph is still going to go from a max of 3 down to a minimum of -3. So max minus min divided by 2, okay, amplitude is 3. Period length remains unchanged because there's been no horizontal stretch. Okay, next graph, there is the replacement. X has been replaced with -x and then -3x. So reflection over the y-axis and then a horizontal stretch by 1/3. Okay, so amplitude would be unchanged. Okay, there is no vertical stretch. The period length, stretching by 1/3 is the same as dividing by 3. So 360 divided by 3 is 120 degrees. Okay. Then we move on to 5 sine of 4x. So a couple of transformations here. So a vertical stretch by 5 means your graph would be going from a maximum of 5 down to a minimum of -5 now. Okay, so max minus min divided by 2, amplitude is 5. X being replaced with 4x, that's a horizontal stretch by 1 over 4, or dividing by 4. So 360 divided by 4 is 90 degrees. That's the new period length for that graph. Okay. And then in the next one, okay, I have 1/3 sine of 1/2 x. So a vertical stretch by 1 over 3. So my graph is now going from 1 over 3 to negative 1 over 3. Max minus min over 2 is 1 over 3. Okay, and a horizontal stretch by a factor of 2. So 360 times 2 is 720 degrees. So when you take a look at these graphs, this is what they want you to get out of this, okay, is that when I have a graph y equals a sine b of x, the amplitude is always going to be the absolute value of a. And I say absolute value of a because if a is negative, we don't worry about the negative. That just means there's been a reflection. It'll be the absolute value of a, so the positive value of a, and the period length will always be, since we're in degrees, 360 degrees divided by the absolute value of whatever the b is. Okay, again, I put the absolute value bars there because if b is negative, that just means there's been a reflection. Okay, so now we're going to go through and talk about, we did D, we completed the table. E is describe the effects of parameter A. So what does A do to your graph? Well, basically all you want to know is that the amplitude, okay, of your graph is equal to the absolute value of A. And describe the effects of parameter B on your graph, sine B of x. Well, your period length, okay, so the horizontal distance it takes for your graph to do one cycle will always be 360 degrees divided by the absolute value of b. Now, if we were in radian mode, it would just be 2 pi over the absolute value of b. And G says, would you expect similar effects on the graph of a cos b of x? Yes, okay, because sine of x and cos of x share a lot of similar characteristics. You know, their period length, their max and min values, those are all shared. So when we talk about their amplitude and their period and how we calculate them, they are identical. Okay. So the effects of A and B on A sine B of x and A cos B of x and A tan B of x. Okay. So here we talk about A, which is your vertical stretch. Okay. So that's what we're talking about here. A is your vertical stretch. If A is bigger than 0, remember that just means positive. Okay. So if it's positive, you just have a vertical stretch. If A is less than 0, which means negative, then there's also going to be a reflection, okay? And the stretch would be by the absolute value of A. So just don't worry about the negative when you're stretching it. The negative just refers to the reflection, okay? Then we move down to B, and we should talk about this, I guess, before I kind of glide past it. Changing the parameter A on tan of x also results in a vertical stretch. We will discuss that and see tan of x in a couple of questions, but it's a little bit different because tan does not have a max and a min value, okay? So when we talk about tangent, there is no amplitude, okay? And you'll see that in the chart below. So it's a little bit different, okay? Now B, the B value, again, if B is bigger than 0, that just means there's been a horizontal stretch, okay, which they mentioned in the write-up here. And we stretch by 1 over b. If b is less than 0, which is negative, that means, again, there's also a reflection, and you're going to stretch by 1 over the absolute value of b. So when we get down to these graphs here, you notice they've broken it up into sine and cos as one group and then tan as another, and this is why. So amplitude, max minus min over 2, period 360 over b for degrees, and 2 pi over b for radian measure. Same calculation, one's just in degrees, one's in radian. For tangent, okay, some things that are very important. There is no amplitude, okay, for tangent, and the reason is there is no max, okay, or min value, okay? And we took a look at that graph of tan of x the other day. And the other key thing is that for tangent, the period length is 180, not 260 or 360. It's 180 or pi, okay? So that is very important, okay, in terms of a difference. And you can see here I'm circling for sine and cos, it's 360 or 2 pi. For tangent, it is 180 or pi. So we will come across that again, and you have to make sure you know that, okay, the difference between sine, cos, and then tangent. So hints for graphing a trig function manually. So when you're given a question and they ask you to graph it without a calculator, here's what you do. You sketch the primary function first, so most likely sine or cos. Adjust the basic graph for any amplitude. Okay, so do your vertical stretch on the graph, and then adjust the graph for any change in period. So then do your horizontal stretch, okay? And I'll show you how to do that here on the next page. So it says, consider the graph of 4 cos of 2x between 0 and 2 pi. So there's your domain. They only want you to draw the graph between 0 and 2 pi. So first thing is they say state the amplitude and the period. So the amplitude that we learned is always going to be your A value, okay? So amplitude, okay, is always the absolute value of A. A is already positive here, so the amplitude is 4. Now the period is a different thing, okay? So what you do to find period length is the following, okay? Remember, the calculation is going to be, and you can see we're in radians here, aren't we? 0 to 2 pi. So the period is going to be 2 pi. That's the normal period length for cosine, which is the graph we're studying. And you divide it by the b value. So what's my b value here? It's 2, right? So it's always 2 pi divided by b. The 2's will cancel, so the period length is pi radians. So for the graph that they have done here, the graph is going to complete one cycle in pi radians, or 180 degrees, if you were thinking in degrees. So remember, we know that cosine, right, normally does this. So again, I always kind of want to have the basic shape of the graph in my mind. Cosine does this, right? Starts at a max at 1, goes down, hits a minimum, and then comes back up to my maximum at 1. This is at 0, this is at 2 pi, and my x-intercepts here are at 90 degrees. Okay, that's pi over 2. Okay, and 3 pi over 2, which is 270 degrees. It hits this maximum value right here at pi. Okay, so there are all the key points that I'm going to move on my graph. Now, here's what I do, right? And if you want, I can draw those points on the graph. So here's what cosine would normally look like. Okay, there's 1. Okay, we set at pi, then I hit -1, and then again at 2 pi, I'm back at that max value of 1. Now the x-intercepts, we want to hit them properly. So I want to take a look at the x-axis scale and figure out what I'm counting by. So it looks like I'm going 30, 60, 90, 120, 150, 180. So each tick on the x-axis here is 30 degrees, or pi over 6 radians. So I want to get to 90. So 30, 60, 90, or pi over 2 radians. There's the first x-intercept, and then 270 is right there, okay, or 3 pi over 2. So if I were to graph just good old cos of x, this is what it would look like, okay? So this is the graph that I'm basically going to make the transformations on, okay, or move those points. So the first thing is I can do my vertical stretch, okay, by a factor of 4. So I'll draw the new graph in red. So if I take this first point at 1 and I stretch it by 4, it's going to go up here, okay, to a value of 4. The x-intercepts will not move anywhere if you are doing a vertical stretch, okay? And again, the graph here at 2 pi would end up there, wouldn't it? And that minimum value here at -1 would go down to -4. So you would have that. There would be your points, okay, at this point. Now, I have to apply the horizontal stretch. Okay, so the stretch is, if I take a look at my equation here, I replaced x with 2x, didn't I? So that means this is a horizontal stretch, okay, by a factor of 1/2. So everything gets cut in half horizontally, okay? So the first x-intercept, okay, that is at 90 degrees, okay, is going to end up right here at 45 degrees. Okay. The point at the bottom, the minimum value, which is at pi, will be at 90. So remember 30, 60, and there's 90. Okay. The next x-intercept, you stretch that by 1/2. Okay. It is going to be, where are we, 1.5. And then the point at 2 pi, which is here, will end up at pi. So I've stretched the graph in half. So now all of a sudden, the graph of cosine looks like this. There's what the graph of cosine looks like when it is stretched vertically by 4 and horizontally by 1/2. But I have to do it again because they want me to graph it all the way between 0 and 2 pi. So that means I'll have 2 cycles of cosine. So I kind of repeat what's just happened. So my next x-intercept will be here because I know every 1.5 units now, okay, on the grid, I'm going to have a new key point, either an x-intercept, a max, or a min value. So I just kind of follow the pattern that I have created. So it goes up, it goes down, then through there, through that point, up. So My graph in black there is my final graph of 4 cos of 2x. I took all the key points, which again were just these points that I'm circling on the sketch on the side, stretch them all by 4 vertically, and then stretch them all by 1/2, okay? Multiply their distance from the y-axis by 1/2, and then we're good. So it says sketch the graph, use a graphing calculator to verify. So you can verify on your calculator, you'll see you get exactly what we got there. Next, writing equations of trig functions. So write the equation of a sine function that has an amplitude of 2/3 and a period of pi over 6. So in this question, what they're really focusing on is, do you know the difference between period length and the b value in your equation? And I'll show you what we're going to do. So since we have that, here's what happens. If I have an amplitude of 2/3, okay, we've learned that that's basically your a value, right? Amplitude is your a value. But the period is pi over 6. I don't put that into my equation. I have to calculate the b value, which is what I want to put into the equation. So the b value is going to be this. Now, since I'm dealing with sine, the basic period length for sine is usually 2 pi. So it's going to be 2 pi over the period length. So remember, this means divided by. So this is like going 2 pi times 6 over pi. So the pi's will cancel. 6 times 2 is 12. That is your b value that you're going to put into the equation. So therefore, your equation will look like this. Y is equal to 2/3 sine of your b value, which is 12, and then x. Okay, so there's your b value. Your b value is not your period. They are related, but they are not the same value. Okay, so let's try another one. This time we're talking about cosine. So again, cosine has a normal period of 2 pi. We'll use that in a second. But again, the amplitude here is 3. So that's really easy. A is equal to 3. But here's the problem. The period is 720. I need the b value. So the b value will be, now this time they're in degrees. So instead of 2 pi, I'd say 360 degrees divided by my period length, which is 720 this time. That reduces to 1/2. So there is your b value for this question. So therefore, my equation will be y is equal to 3, the amplitude, cos of 1/2. There's the b value, x. Okay. All right, last one. Okay, star beside this one because we are discussing tangent. So again, the reason that we deal with tangent and make such a big deal about tangent is because its period length is 180 degrees or pi radians, not 360 or 2 pi like it is for sine or cosine. So notice there's no a value because remember, tangent does not have an amplitude. So therefore, we're just worried about this, the period being pi over 2. So when I go and do the b value, we're in radians here, pi over 2. I take the normal period length for tangent and divide by the period length in this question. Remember, this means divided by. So this is like pi times 2 over pi. The pi's cancel. So you are left with 2. So therefore, your equation here would simply be y is equal to the tangent of 2. There's your b value, x. Okay, and there's your final equation. Sometimes they'll give you questions like this, where they don't give you a lot of write-up about the characteristics of the question. You have to determine those from the graph or the picture that is provided. So again, first off, state the amplitude and the period of the graph. So when I do amplitude, remember it's max minus min over 2. We have to know that formula. So the max that this graph goes is 3. So there's the max minus the minimum, which is -3. Then I divide by 2, okay? So 3 minus -3 is 6, divided by 2 is 3. So there is my amplitude. The period length, okay, remember, is the length of time it takes the graph to do one complete cycle. So I want to find a point and then find where that point occurs again. So if I start here and I follow the graph, it goes up, it goes down, and then it comes back up. At this point, there's one complete period, okay? It would start to do the same thing again. So the period there is how far? Well, this is pi here, isn't it? Right? Pi over 2 is 90. 3 pi over 2 is 270. So right in the middle is going to be pi. So the period length here would just be pi radians, okay? That's how long it would take this graph to do one complete cycle, okay? Pi radians. Now, determine the equation. So when I go and write the equation, and they've told me that it is a sine function, it's going to look like this, right? Y is equal to 3 sine of, but now I need a b value. The b value, remember, just like above, is calculated by taking the normal period length for the graph I'm discussing, so 2 pi because it's sine, and I divide by the period length of the graph that's given. So you can hopefully see the pi's will cancel. Your b value is going to just be 2. So then I go into my equation, replace the b value with 2, and there's your equation, okay? 3 sine of 2x. All right, last question for today. It says the graph represents the effect of tides on mean sea level over a 24-hour period. The graph has the following equation. H of t, okay, which is like your y value. Oops, I apologize. Okay, h of t, which is like your y value, which you can see is also labeled here, okay, on your y-axis, and a cos b of t. So that's like your x. That's the x-axis right there, okay? Where t is time in hours and h is the height in meters relative to the mean sea level, determine the equation of the graph. So really what you need to do is figure out the value of a and the value of b. So very similar to the last question, except they don't walk you through it step by step. So if I want the a value, okay, well, a is going to be equal to, well, the amplitude. So max, which the highest it goes is 4, and the lowest it goes is -4. So the amplitude, or a value, would be max minus min all over 2. So that's going to be 8 divided by 2, which is 4. So there's your a value. You're done. The next thing you want to do, okay, is you want to determine the period length, okay? So again, we should be able to get that from the graph. So if I find a point and find where that occurs again, let's say I start at this maximum, okay, notice here it goes down and then it turns, comes back up, hits that maximum again. There is one cycle. So the horizontal distance from there to there, okay, if you look at the scale, 3, 6, 9, that's 12, okay, so that's going to be 12 hours. Again, that's not the only way of doing it. I could have gone along the x-axis. I could have gone max to min and then multiplied by 2. But that was just the easiest point that I saw at this point in time. So that's the one that I used. So I know that the period, like I said, is 12 hours. But that's not the b value, right? So therefore, the b value will be equal to the normal period length for cosine, which is 2 pi. And I divide by the period length for this case, which is 12. So when I do that, okay, the 2 and the 12 will reduce to 1 over 6. So the b value is going to be pi over 6. That's what I put in for b. So therefore, when I go and write my equation, it'll look like this. H of t is equal to the a value, that was 4, cos of my b value, pi over 6, and then I use the variable for the question, which is t. So 4 cos of pi over 6t is the equation for this graph. Okay, and that's it. So practice that, you guys. Again, just it's applying basically transformations to the graph of sine and cosine, and like you saw, once in a while tangent. Just remember the differences between sine and cos and tangent in terms of the period length, and that amplitude does not exist for tangent. Any questions again or concerns at any point, get a hold of me and I will get back to you. All right, take care. Have a